The whispers are over. The shadows have receded. Today, May 29, 2025, marks a pivotal moment. The United States Air Force has confirmed it. The SR-72, codenamed DARKSTAR, is real. This is not a Hollywood fantasy. It is a tangible piece of advanced engineering. A new era of air dominance is dawning. Global power dynamics will shift. This aircraft changes everything. The future of aerial warfare has arrived. Lockheed Martin's Skunk Works is the birthplace of legends. The U-2, the F-117 Nighthawk, and the SR-71 Blackbird all emerged from its secretive hangars. These aircraft redefined aerial capabilities for their time. The SR-72 DARKSTAR is the latest scion of this extraordinary lineage. It is often called the son of Blackbird. This moniker speaks to its heritage and ambition. The DARKSTAR aims to surpass its legendary predecessor in every critical aspect. Development has been an intense, focused effort. New production facilities suggest manufacturing is well underway. The path to the DARKSTAR involved years of dedicated research. It built upon decades of hypersonic exploration. Data from programs like the DARPA Falcon Project's HTV-2 proved invaluable. The HTV-2 reached incredible speeds, Mach 20 in tests. This provided crucial insights into hypersonic flight dynamics. It helped engineers understand aerothermal effects. It informed the design of the SR-72's airframe. This knowledge was essential for creating a controllable, survivable hypersonic platform. Skunk Works engineers meticulously refined designs. The DARKSTAR is their next masterpiece. The SR-72 DARKSTAR is engineered for outright speed. It is designed to achieve and sustain Mach 6. That is over 4,600 miles per hour. This is nearly double the speed of the SR-71 Blackbird. The Blackbird topped out around Mach 3.2. Such velocity makes the DARKSTAR almost untouchable. It can outrun most current air defense missiles. It makes continuous tracking by enemy radar exceptionally difficult. Speed is its primary armor. This capability alone redefines survivability in hostile airspace. It allows access to areas previously considered too dangerous. The DARKSTAR's operational altitude is expected to be around 85,000 feet. This is similar to its predecessor, the SR-71. Flying at the edge of space provides a significant advantage. It enhances surveillance reach and complicates enemy interception efforts. Combined with its extreme speed, this altitude makes it a formidable platform. The engine technology enabling this performance is revolutionary. It uses a turbine-based combined cycle (TBCC) system. This allows the DARKSTAR to take off from a runway like a conventional jet. It then transitions to a scramjet for hypersonic cruise. Stealth features are undoubtedly integrated into the DARKSTAR's design. The airframe itself is a marvel of material science. The DARKSTAR is truly built for extremes. The SR-72 DARKSTAR is not just a reconnaissance aircraft. Unlike the SR-71, which was primarily an intelligence gatherer, the DARKSTAR is designed with strike capabilities from its inception. This marks a significant evolution in strategic thinking. It will serve as a penetrating intelligence, surveillance, and reconnaissance (ISR) platform. It will also be capable of delivering precision strikes. This dual-role capability makes it an incredibly versatile asset. It can find targets deep within enemy territory and engage those targets rapidly. This dramatically shortens the sensor-to-shooter timeline. As an ISR platform, the DARKSTAR offers unparalleled advantages. Its ability to fly at Mach 6 in high altitudes means it can cover vast areas quickly. It can gather critical intelligence in denied airspace. This information can be relayed in near real-time to commanders. The speed allows it to respond rapidly to emerging threats or targets of opportunity. The strike capability of the DARKSTAR is a game-changer. It is expected to carry advanced hypersonic missiles. The DARKSTAR may also feature advanced autonomous systems. It is a truly multifaceted weapon system. Section 5. Echoes of a Legend, SR-71 and the SR-72 Evolution. The SR-71 Blackbird was an icon of the Cold War. It flew higher and faster than any other jet of its time, reaching speeds over Mach 3.2 and altitudes of 85,000 feet. Its Pratt & Whitney J58 engines were unique. Its titanium skin was revolutionary. For over 2 decades it provided critical intelligence. Over 4,000 missiles were fired at SR-71S. None found their mark. This record cemented its legendary status before its retirement in 1999. The SR-72 DARKSTAR builds upon this legacy. It aims to achieve what the SR-71 did, but in a new era. The primary improvement is speed. Mach 6 for the DARKSTAR versus Mach 3.2 for the Blackbird. This leap in velocity enhances survivability. It reduces transit times to target areas. While the SR-71 was unarmed, the SR-72 is designed for strike missions. This adds a potent offensive capability. The DARKSTAR is not just about seeing, it's about acting. This is a fundamental shift in operational philosophy. The SR-72 employs a sophisticated turbine-based combined cycle, or TBCC engine. The DARKSTAR represents a generational leap. Section 6. Forged in Fire, Overcoming Hypersonic Engineering Frontiers. Developing an aircraft that can consistently operate at Mach 6 is an immense undertaking. One of the most significant hurdles is thermal management. At such extreme speeds, air friction generates incredible heat. The leading edges and engine components can reach thousands of degrees. The SR-71's titanium skin glowed red-hot. The SR-72 faces even more severe conditions. Engineers have had to pioneer new materials. Carbon-carbon composites often used in re-entry vehicles are essential. Ceramic matrix composites, or CMCs, are also critical. These materials maintain structural integrity at extreme temperatures. Another major challenge is maintaining stable flight control at hypersonic speeds. The aerodynamics are incredibly complex. Airflow behavior changes dramatically as an aircraft crosses the sound barrier. It changes again as it enters the hypersonic regime. The Air Force Research Lab, or AFRL, has been working on boundary layer phenomenology. This research aims to ensure smooth or laminar airflow around the aircraft. Turbulent airflow can create drag and cause localized overheating and instability. Mastering hypersonic aerodynamics is key to the DARKSTAR's success. The DARKSTAR must operate at the edge of known engineering limits. Section 7. The Mach 6 Era Deployment and Strategic Reshaping. The anticipated timeline for the SR-72 DARKSTAR is aggressive. Its first flight is predicted for this year, 2025. This is a remarkable achievement for such an advanced program. If flight testing proceeds as planned, the aircraft could become operational by 2030. This is not far off. This means the United States is on the verge of fielding a truly revolutionary military capability. The deployment of the DARKSTAR will send ripples across the globe. It will force potential adversaries to reassess their defensive postures. It will reshape strategic calculations. The significance of the DARKSTAR and future military strategy cannot be overstated. Its ability to penetrate contested airspace is crucial. Modern anti-access or area denial, known as A2/AD, systems are becoming increasingly sophisticated. They pose a significant threat to conventional aircraft. The DARKSTAR's extreme speed and high operating altitude provide a powerful counter. It can bypass many current defenses. It can hold targets at risk that were previously considered safe. This capability enhances deterrence. It also provides new options for power projection. The DARKSTAR will be a critical enabler for other forces. The operational deployment of the SR-72 will mark the true beginning of the hypersonic era in air warfare. Section 8. America's Future Edge DARKSTAR and Air Power Modernization. The SR-72 DARKSTAR is a cornerstone of America's broader air power modernization. It does not exist in a vacuum. It is part of a comprehensive strategy. This strategy aims to ensure air superiority for decades to come. The Air Force is also developing the B-21 Raider stealth bomber. This aircraft will provide long-range strike capabilities. Collaborative Combat Aircraft, or CCA, also known as Loyal Wingman drones, are also planned. These will augment manned fighters and bombers. They will increase mass and complexity for adversaries. The DARKSTAR complements these efforts perfectly. The development of these advanced platforms is a significant investment. The B-21 program involves 100 aircraft. The CCA program aims for 1,000 drones. The Next Generation Air Dominance, or NGAD fighter program, though currently under review, was also ambitious. Adding an estimated 5 SR-72s, each costing nearly $1 billion, highlights the commitment. These programs represent a substantial portion of the Air Force budget. This underscores the perceived importance of maintaining a technological edge. The DARKSTAR, with its unique hypersonic capabilities, fills a critical niche. The DARKSTAR ensures that the United States can operate effectively and project power when necessary.